All right, so we're going to review Chapter 1 in Algebra 1, whether you're in 1A, Algebra 1, 1B, it's all the same, Chapter 1 here. We're going to review that in our little test review. It's 25 questions. This is not multiple choice, but your test online that you're going to take through Schoology is multiple choice, so you don't have to worry about that. This is a little more difficult, but hopefully you'll understand. Email me or message me any questions you have after this. You're welcome to pause the video before you watch me work through something. See if you can work through it yourself first, and then check your answer with me. Okay, for 1 through 4, write an algebraic expression for each verbal expression. So we're just translating. So here we have the sum of, so sum is plus, so we're adding things, but we don't know how many things we're adding, so we're gonna look for the word and. So if we're adding 3 things, this and this and this, we're gonna see the word and twice. If we're adding 4 things, we'll see the word and 3 times, right? If we're just adding 2 things, we're gonna see the word and once. And here I see the word and, so I know that my plus sign is going to go in between this term right here and this term right here. So what are those 2 terms? The sum of the cube of a number, and it doesn't tell me what the number is. This does not mean, well, they don't say what the number is, so do I just make up a number? No. In math, remember, we use a variable whenever we don't know what a number is, right? So we're gonna use X, or you can use any letter of the alphabet, it doesn't matter. You'll get the answer the same, it'll be correct, no matter what letter you use, and it's the cube. X cubed, which means X to the 3rd power. So the sum of the cube of a number and 12. So we're adding X cubed plus 12, right? So that's what we would write over here, X to the 3rd power plus 12 over on our answer key. Okay, number 2, 42 decreased by twice some number. So this is minus, so I'm gonna put a little minus sign here. What am I subtracting? Well, I start with 42, and then twice some number. If you do something twice, you do it 2 times. So twice means 2 times. 2 times some number. And when we don't know what the number is in math, remember we use X again. So 42 decreased by twice some number, 2 times X. Twice X, 2 times X. So I write that over on my answer sheet. This whole document is in this folder too, by the way, so you can pull this up and print it and write on it if you want. You are not required to print anything here, so you can also write on your own paper. But please don't waste this opportunity to do a review. This is gonna tell you how well you know this stuff and if you're ready to take the test or not. All of this material rolls up into your Algebra EOC. So yeah, there's probably easy ways around reviewing, right? Maybe you just skip it, maybe you just turn something in and hope for the best, right? But really, you know, be young adults about this and use this to your advantage and really try and learn and follow the videos and see what you know and what you need to review more of. All right, number 3, write a verbal expression for this whole thing here. I don't want to say it out loud because I'll confuse everybody. So we're writing a verbal expression now. We have to write words. So what's happening here? How many different operations do I have? Well, I'm multiplying 6 times this G term. I'm squaring the G term. I'm raising it to the second power. And I'm dividing all of that by 5, right? So there's quite a few different ways I can represent all of these. The order I can represent them in is going to be completely different. As long as if somebody else came along and read your verbal expression and could translate it to this exact algebraic expression, then you're good. If they read it and they translate it and it looks different than this, then you might have written something incorrectly. So you have to watch how you're writing it. Okay, so first I'm going to represent the division. So I'm going to say the quotient of. So now I have to name my 2 terms. What am I dividing? I'm dividing 6g squared by 5, right? But I can't just say 6g squared. I have to say what the 6 and the g are doing. I can't just say 6g and assume people know what that means. I have to say divided by or times or plus or minus. So I'm going to say the quotient of 6 times g squared, 6 times g squared and 5. So remember, if we were translating this, I see the quotient of, so I ask myself, okay, what am I dividing? And I look for my and sign. And the terms that I'm dividing are in the front and behind the and sign. What two things am I dividing? I'm dividing 6 times g squared and 5, because they're on either side of the and sign. Okay, so hopefully that makes sense. I'll just leave it there. There's not room to write it over here. And lastly, evaluate, number 4. I have an extra sheet of paper here to use. Here we go. We want to simplify this expression. For me, I have to rewrite the whole thing just to kind of spread it out a little bit. So I've got 4, and then brackets, which are just like parentheses. 3 to the 3rd power minus 5 times 8 minus 6. Now, for me, I'm going to write out every single step, so this is going to look a lot longer. Probably some of this, as you guys get more comfortable and familiar with everything, you can do some of it in your head. That's perfectly fine. For now, if you're not super great at it, if you don't get every single one of these kind of problems correct every single time you do it, if you're making silly mistakes, you need to get in the habit of writing out every single step. And the more you do every single step, then the more your brain's going to see it, and then the easier it's going to be for you to just kind of start doing it in your head as you get super comfortable. But you definitely don't want to risk making the silly mistakes. Okay, so first thing I want to do here, I'm following PEMDAS, right? Anything in parentheses, and brackets count as parentheses. The only reason we use brackets is because there's another set of parentheses inside it, and sometimes it gets confusing when you see 2 sets of parentheses. So they use brackets to just kind of separate it, make it look different. Okay, so first thing I want to do is this 8 minus 6, which is 2. So instead of writing the whole thing, I'm just going to cross it out and put a 2 here. Okay, now I have inside brackets, this is where I'm focused on, simplifying everything in brackets. I have exponents, 3 to the 3rd minus 5 times 2, right? 3 to the 3rd power means 3 times 3 times 3. 3 times 3 is 9, 9 times 3 is 27. So I am going to rewrite this for bracket 27 minus 5 times 2 in bracket all over. And there's no parentheses on the bottom here, and the top's not affecting the bottom yet, so I am going to go ahead and simplify this exponent too, since I'm on exponents at this point. So 3 squared is 9 minus 7. Okay, so this is my next step down. I needed a little bit up here. Now I'm still inside these brackets. That's my focus. So I'm going to simplify everything. So I have a minus sign and I have multiplication. Well, over here, addition and subtraction come after multiplication and division. So I want to multiply first before I subtract. So I'm going to change this to 10. So now I have 27 minus 10 in brackets. So I can rewrite that. I'm going to write it to the side here. For bracket, 27 minus 10 is 17 over 9 minus 7, and I didn't rewrite this plus 11, but it is still there. You need to make sure you don't leave stuff off from line to line. I was focused on just the fraction. Okay, so now I still have the top here, I have multiplication. The bottom, I have subtraction. Once I get these both down to one number, I have to actually divide them, and whatever I get there, I'm going to add 11. So next, I'm going to do my multiplication. 4 times 17. Well, I know 4 times 10 is 40, and 4 times 7 is 28. All I did in my brain was separate 17 into 10 plus 8, and then I distributed the 4. 4 times 10 is 40. 4 times 8 is 28. 40 and 28 is 68. So I've got 68 on top of my fraction. On the bottom, just because they're not affecting each other yet, I can go ahead and simplify. 9 minus 7 is 2. And then I still have this plus 11 out to the side. So then lastly, 68 divided by 2 is 34. And 34 plus 11 is 45. So our answer here is 45 for number 4. 45 using order of operations. I was trying to say process of elimination. Okay, next. Evaluate each expression. If W equals 4, N equals 8, V equals 5, and T equals 2. So you might use all of those, you might not. So we're going to look at number 5 first. For number 5, all I'm going to do is substitute. That's it. So W is 4. So I'm going to write 4 squared plus N, which is 8, times v squared, v is 5, so 5 squared, minus t, t is 2, and then in parentheses. So this is what I'm actually evaluating, right? All I did was substitute. Okay, so I'm going to do my parentheses first, then my exponents, and simplify from there. Still following PEMDAS. 5 squared is 25. So 4 squared plus 8 times 25 minus 2. 25 minus 2 is 23. So 4 squared plus 8 times 23. Then I have exponents. Now some people say, but you still have parentheses. You're right, I do still have them, but I've simplified everything inside of them. That's what the P in PEMDAS is for parentheses. It means simplify everything inside parentheses until you can't simplify it anymore. And there's nothing else I can do to 23. So now I move on to my exponents, 16 plus 8 times 23. And now I've got addition and multiplication. I can't just add 16 plus 8 and then whatever that is, multiply it by 23. I have to multiply first using order of operations. So 16 plus, and in my brain, I'm going to separate 23 into 20 plus 3, right? And I'm going to distribute that 8. In my brain, I'm not distributing. I'm just saying, okay, what's 8 times 2? 16. So what's 8 times 20? 160. 8 times 3 is 24, so 160 and 24 is 184. So I've got 16 plus 184, and when I add those together, I get 200. So our answer here is 200 for number 5. And then number 6, we're going to do the exact same thing, just plugging in, because it is a different problem. Oops, sorry. I get to like look at my phone to see what you guys can see. All right, so we have 3 times n times w. 3 times n is 8, w is 4, minus w squared, 4 squared, plus t to the 3rd power, so 2 to the 3rd power. Okay, so here, parentheses first. Yes, I have parentheses, but inside those parentheses, there's nothing to solve, right? This is actually all multiplication, which comes after exponents. So after parentheses are all simplified, which here they are, we don't have to do anything, then we simplify all exponents. So I've got, oops, I don't know why I just wrote a 4. 3 times 8 times 4 minus 4 squared is 16. 2 to the 3rd power, 2 times 2 times 2 is 8. Okay, so now I've got multiplication, subtraction, addition. And in PEMDAS, I have to multiply before I can subtract or add, right? So 3 times 8 is 24. 24 times 4 is 96. And now I have subtraction and addition. Don't forget with PEMDAS, I'll write it out here real quick. Just because it's written in this order to help us remember it, these two are actually equal operations, which means if you have a problem with division and multiplication in it, you don't have to multiply before you divide. Once you get down to these operations, they're the same. So you can just solve them in order from left to right. Sometimes you might have to divide first and then multiply, sometimes vice versa. That's the same thing with adding and subtracting. They are equal operations. So I don't have to add this before I subtract. I'm actually just going to solve it in order from left to right. These are my last steps. They're equal operations, just solve. So 96 minus 16 is 80, and 80 plus 8 is 88. So for this problem number 6, I get 88. Hopefully that makes sense to you guys. All right, so 7 and 8 now. So for both of these, we have to name the property used in each equation, the property shown in each equation, and then solve for n. So when they show these, even though we see an n here, you're supposed to magically pretend that we already know what n is, right? So if we actually had n correctly filled out and put in here, what is this showing? Well, if we know what n is, we know it's going to be 1, right? So this basically says 7y plus y equals 7y plus y. Once we solve for n, we know this y. So whenever you have both sides of your equal sign look exactly the same, that is the reflexive property of equality. When both sides look the same. So in order for both sides to look the same, n would have to be equal to 1. Right? And if we solved this for n, I have a sheet of paper here. If we actually wrote it out and solved for n, here, 7y plus y equals 7y plus ny. First, I would start by subtracting 7y from both sides of the equal sign. These go away, so I'm left with y equals ny. And then I'm solving for n, so to get n alone, I want to get rid of this y. So I've got to do the same thing on this side. These y's cancel out. Y divided by y is just 1. That's what it is over here too, and 1n is just n. So we get n equals 1 or 1 equals n. So we know n has to equal 1. Once we go back and put a 1 in there, what property is shown? The reflexive property. You can write it over here on the side. I'm just going to leave it here. And then number 8, same thing. They took this problem and wrote it out, pretending that we already know what n is. So here, it looks like what they did was use the distributive property. The distributive property, because what did they do? They distributed that x to the 6th term and the n term. I'll show you what I mean. Hopefully this is pretty easy for you guys. I'm trying to use the same sheet of paper and fold it so you don't see all the junk from the last problem. All right, so 6 plus n times x equals 15x. They took this x and they multiplied it by the 6 and by the n. So they got 6x plus nx equals 15x. And if they both have an x term, that means we had to add what was in front, right, to get this number. Also, what you could say is that everything's being multiplied by x. So if we're trying to solve for n, we can divide everything by x. These x's go away, these x's go away, and we would be left with 6 plus n equals 15. Subtract 6 from both sides of my equal sign, and n equals 9. Right? So if we went back here and said 6 plus 9 times x equals 15x, this would be distributive property, right? They distributed. You could also say, I guess, substitution. You could say we replaced this value with 15. That would work as well. I would accept either answer. This is where the multiple choice comes into play, because they would not give you both of these answer choices unless it said select all that apply. But either one of these I would accept. You could use distributive property, or you could use substitution, replacing 6 plus n with 15, since they're equal. That would probably actually be more accurate. And then here, n equals 9, like we said. Okay, sorry if that was confusing. Number 9, evaluate. Name the property used in each step. So this one we actually have to write out. Let me get another sheet of paper. So what I would do, my trick to using each property, naming the property used in each step, is just to solve this line by line. Don't do any work in your head. Every single thing you do needs to get written down, okay? So we have 2/3 times 3 divided by 2 plus 3 squared minus 9. Okay, first thing I'm going to do is start simplifying what's inside parentheses, right? So I'm going to replace, well, I'm not going to replace. This is 3 over 2. I can rewrite it. That's not substitution. I'm not changing it. It's still 3 divided by 2. I'm just going to write it like 3 divided by 2 that way. So it's the same thing. It's not substitution. I didn't change anything yet. Plus, but I am going to change this. 3 squared is 9. So 9 minus 9. Okay, so going from this step to this step, what property did I use? All I used was, for this side, I replaced 3 squared with 9. That is substitution. If I had changed the numbers over here, then this would have been substitution as well. But I literally just rewrote 3 divided by 2 as 3 divided by 2. So I did not substitute anything anywhere. Okay, next I have to keep simplifying what's inside parentheses. I can't do anything here, but I can do something here. So this is 2/3 times 3/2 plus. Now I want you to think of 9 minus 9, because this is a property that you guys had. Think of it as 9 plus negative 9, right? It's the same thing. You get the same answer. We're thinking of this as 9 plus negative 9, right? And if you saw this, you would say, okay, well, there's 2 signs touching. I can't have that. So I'm going to replace, since they're different, replace them with a minus sign, and you would get 9 minus 9. But it's really the same thing as 9 plus negative 9. And our property that we use is the additive the additive inverse property when we add numbers that are opposite and the answer is 0. So I'm adding 9 and negative 9, and the answer is always going to be 0. So here, I'm going to simplify that. And going from this step to this step, when this is all I changed, this is the additive inverse property because I added opposite numbers and got 0. Additive inverse. I know that a lot of you guys are gonna like kind of balk at that a little bit and say, well, no, because I'm not adding, I'm subtracting. Okay, but think about it. You specifically learned a property that was the additive inverse. We didn't learn a subtraction property. You learned an addition property that said when you add opposite numbers, the answer is always 0. And here we're saying positive 9 minus 9, or 9 plus negative 9, and the answer is 0. So you can't tell me that they're that close. They're the same thing, but because this is a minus sign and not a plus, you're not going to use this. Like, come on, they're close enough. Anytime you have a number minus itself or adding its negative self, and the answer is 0, it's always the additive inverse. Okay, so the next, I have multiplication and addition. So I'm going to start with multiplication. So I know this number is being multiplied by its reciprocal, right? It's being multiplied, and all we did was flip this fraction over to get this one. So 2 times 3 over 3 times 2 would be 6 over 6, which is 1. And we have a property there that we used, going from here to here. That is the multiplicative, or you can say multiplication. I'll just put multiplic, abbreviated, inverse. So when we add inverses, we're using opposite signs, right? When we multiply inverses, we're flipping them upside down. We don't care about the signs when we're multiplying. We only care about them when we're adding, right? So multiplication or multiplicative inverse is when we multiply a fraction by its reciprocal and we get 1. And we didn't touch this over here yet. All right, last thing is we said 1 plus 0. We added 0 here, and the answer, of course, is 0. So what property says that if I start with a number and I add 0, that number keeps its identity. It stays the same. Well, I'm adding, and my number stayed the same. It kept its identity, so this is the addition or the additive identity. Additive, I'm trying to add too many T's. Additive identity. Okay, so that was just us simplifying step by step, and we showed which property we used in each step. And of course, like I said, your test on the computer you're going to take this week does not have, it's multiple choice. It does not have fill in the blank or anything. So you won't have to complete an entire problem yourself, but it could give you all of these steps, and instead of giving you all the properties, maybe take out one of them and leave a blank, and you had to fill in the blank. So you do need to understand, okay, from this line to this line, what did I do? I'm going to write that reason here. From this line to this line, what did I do? I'm going to write that property here. Here to here, what did I do? Right here. That's all we're doing. Okay. So we'll say C paper. All right, number 10. Rewrite this guy using the distributive property and then simplify. So all we're going to do is take this 2 out front of the parentheses, and we're going to multiply it by each term inside parentheses, right? Just like that. So 2 times x is 2x. Bring over my plus sign. 2 times 3y is 6y. Then there's a minus sign. And then 2 times 2z is 4z. And is there an equal sign? No. And we have 3 different variables. So we can't do anything beyond this. We can't combine anything to simplify because they're all different variables. And there's no equal sign, so we can't solve for the variables. Okay, so this is our simplification here. We're going to write 2x plus 6y minus 4z in our answer box there, and we're done. Simplify each expression. If not possible, write simplified. So some of these might already be done. Okay, 11. 3 plus 6 times blah, 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 plus 9na. Well, to me, this is not already simplified because I can distribute. So I'm going to distribute that 6. So I'm going to have 3 plus 6 times 5 is 30a, plus 6 times 4an is 24an, and then I have this plus 9na hanging off the end. Now, are an and na, are these the same terms? Yeah, they got to be difficult, right? Make it look like confusing. But all this term is multiplying 24 times a times n. All this term is multiplying 9 times n times a. So since you're multiplying the same terms here, even though they wrote these letters backwards, they're still like terms. You can combine them because they have the same variables with the same exponents. So now I'm going to simplify. So I've got 3 with no variable plus 30 with just one variable, and then plus, and I'm going to combine these two, 24 and 9 is 33, and you can either write an or na. Either one of those would be correct. So this is our correct answer for this one. Okay, then we've got 12, 7a plus 7a squared plus 14b squared. So yeah, it pretty much is simplified already. We could argue, which would be working backwards, but if we had to touch something, right, we could argue that everything could be divided by 7. So then I would rewrite this with the 7 out front and everything left over after I divide inside parentheses. 7a divided by 7 is a. 7a squared divided by 7 is just a squared. And 14b squared divided by 7 would be 2b squared. So you could say this, that would be changing it. In my opinion, it's already simplified because if I saw this problem, I would go ahead and distribute, right? They've already distributed here. None of these terms are like terms. This a has an exponent of 1. This one has a 2, so we can't combine. This is a b squared, so we can't combine, so we're done. So if you did this route, I'd probably give you partial credit for it because you tried to do something. You recognized they were all being multiplied by 7, but that would be moving backwards. So I would just write simplified here. All right, number 18. I hope it's not confusing you guys how I talk through everything. That's how my brain works. I don't know. All right, evaluate each expression. We're using PEMDAS again. PEMDAS. Order of operations. All right, so we have multiplication, addition, 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 multiplication. So I have to multiply before I do any adding. So I'm going to multiply 6 times 8, which is 48. Then I'm adding 29, adding 7, adding, and then 3 times 7 is 21. Okay, once I do that, the rest of it doesn't matter. When all I'm doing is looking for the answer, and everything's being added, it doesn't matter what order I add it in, right? So if I added 21 and 29, the 1 would make this a 30, 30 and 20 is 50, and then 48 and 7 is 55, so this would be 105. All I did was group. I put this guy with this guy, mental math, and I put this 7 with the 48. I split up the 7 into 2 plus 5. So that 2 made the 48 a 50, and then I still had 5, so 50 and 5 is 55. Okay, and then now in number 14, I have plus times plus times plus. I know I have to multiply before I add. So I'm going to have 32 plus 6 times 4 is 24 plus 7 times 4 is 28 plus 16. Okay, and then again, mental math, I'll actually write it out this time. In my head, I see a 2 and an 8, and I automatically know a 2 and an 8 add up to 10. So if I add 32 and 28, I know that the 2 and the 8 are going to be 10, and then the 30 and the 20 are 50. So together, they're going to add up to 60 for the 32 and the 28. And then the 24 and the 16, the 4 and the 6 are 10. The 20 and the 10 are 30. 30 and 10 is 40. And then 60 and 40 is 100. Right? Work smarter, not harder. If you can add it a lot quicker in your head, then you go for it. But to me, I'd rather put numbers together that add up to tens or easy stuff than trying to, okay, 32 plus 24 is 56, plus 28, well, that's almost 30, so that's 86, but it's minus 2. 84 plus 16 is 100. You can do that if you want, but to me, this was a lot quicker. It's whatever works for you. All right, 15, solve for x. So again, we're just simplifying. That's all we're doing here. You'll see this okay? I'm blind, so I can't see stuff. All right, for 15, top of the fraction first. Before we do anything to the top, we got to simplify the bottom and get rid of it. Actually, we don't. We'll just... X is over here. Never mind. Forget that. Strike that. We're just simplifying the top first. So we have multiplication, exponents, subtraction, multiplication, exponents, and addition. We're going to do the exponents first. PEMDAS, P-E. The exponents are the E. So 5 times 2 times 3 is 8 minus 4 times 3 squared is 9 all over 1 plus 3. And I squished it there. Sorry. Then I'm going to multiply. So 5 times 8 is 40 minus 4 times 9 is 36. And then it's still over the bottom. And I can go ahead and add the bottom now since it's not affecting the top yet. 1 plus 3 is 4. Okay, so I'm going to keep going. 40 minus 36 is 4. And I still have this 4 on the bottom. And 4 divided by 4 is 1. And that's all equal to x. And remember in algebra, whenever you write your final answer, you want to have x first. Either one of these is correct. Sorry. Either one of these is correct, but this is written the completely simplified way, the correct proper way to write it. Okay, and then 16. Find the solution of 2b plus 1/2 equals 3 if the replacement set is blah, 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 blah. Let me back up. Okay, remember the replacement set is just giving us choices. So we're still going to, uh-oh, we're crooked. I think my fat fingers are setting off the camera because they're closer. Okay, we're still going to solve for B, and then whatever we get for B, if it is in the replacement set, then that's my solution set. If it's not here, and none of these answers work for B, then I would say there's no solution in the solution set. Okay, so here, first thing I want to do is get rid of 1/2. So I'm going to subtract 1/2 from both sides of my equal sign. Minus 1/2. These 1/2s cancel, so I have 2b equals 3 minus 1/2 leaves me 2.5. If you have $3 and you get rid of 50 cents, you're left with $2.50, right? And then I want to divide by 2, so I got to divide this side by 2. Well, that's a little tricky, right? Because I have a fraction. How do I divide by a fraction? Well, this is 2 1/2 divided by 2. So I'm going to use keep it, change it, flip it, right? Keep the first fraction the same, change my sign to multiplication, flip the second number upside down. So first I got to make 2 a fraction, so I put it over 1. I'm going to change this mixed number to an improper fraction. So 2 times 2 is 4. I add that to the top, so I'm left with 5 over 2. 5 over 2. I keep the first fraction the same. It's 5 over 2. I didn't do anything to it. I just changed it into an improper fraction. I'm going to change my sign, and I'm going to flip the second fraction upside down. Okay, now I can multiply straight across the top, straight across the bottom. So 5 times 1 is 5. 2 times 2 is 4. So this is 5 over 4. So if we look at our answer choices here, are any of these answer choices 5 over 4? Why, yes, they are. This little bad boy right here. So we had 1 over 2, which is 2 over 4, 3 over 4, 4 over 4, which they simplified to 1, 5 over 4, 6 over 4, which they simplified to 3 over 2, and 7 over 4. So our answer is 5 over 4. All right, and we're on to the last page. We're almost done. Sorry, this is a super long review, but I hope it helps. Okay, so for this one, a little word problem. Some warehouse stores charge members an annual fee to shop there. Think like Costco. On his first trip to a warehouse store, Mr. Marsh pays $50 in a membership fee, and then cases of bottled water there cost $4. Write and solve an equation to find the total amount Mr. Marsh spent on his first trip before tax if he bought 8 cases of water. And this whole before tax thing doesn't matter. They didn't mention tax to us. It's just Some of you smarty pants out there say, well, I know when I buy something, there's tax. So what? Just ignore that for right now. This is a simple math problem. Ignore the tax. Okay, so for our equation here, we are going to say that what are we looking for? The total cost. Find the total amount. So we're going to say the total amount equals, he paid a membership fee one time, 1 year, right? So $50, plus he buys cases of water, and each case of water is $4. So we're going to say 4W. For 4W. So that's our equation. And then it says to solve it if he buys 8 cases of water, right? So if we put in 8 here, if I did A equals 50 plus 4 times 8, what would my answer be? 4 times 8 is 32. 50 and 32 is 82. So $82. All right, number 18, the graph shown represents a puppy exploring a trail. Describe what's happening to the graph. Is the function discrete or continuous? We didn't explicitly go over discrete or continuous, but I'll explain what that is, just so you know. I don't think there's anything on your test about discrete or continuous, but this is what it is if you have a question. All right, so this is the graph This is the graph they're talking about. It got a little displaced up here, but it does go with this problem. Distance from the trailhead, time. So as time passes, right? 1 hour, 2 hours, 3 hours, 4 hours. As time passes, this is the distance from the trail a puppy is getting as he's exploring, right? So as time goes on, the puppy gets a little further away from the trail, and then he doesn't get much further away from the trail. Kind of walks next to the trail for a while. Then he explores a little bit more. Then he gets tired of that, and he kind of stays where he's at. And then he comes back to the trail after a while, right? So distance from the trailhead, he gets a little farther away, then he kind of stays parallel to the trail. Then he gets a little further away, then stays parallel, and then he decides, okay, it's time to come back, and he finds the trail, and he comes all the way back. So all we're doing here is describing what's happening. Is the function discrete or continuous? Discrete means that when you were drawing our line here, the solutions to the function that this is a graph of can be anything in between, any of these in-between numbers, right? So if we talked about money that you earn per hour, right? And if they prorate it or whatever. Well, for 1 hour, if you earn $9 an hour, you could earn half of that in 30 minutes, right? If you're on the clock. Or a quarter of that if you only work 15 minutes. So you can earn not only on the hour, but all the stuff in between as well. So when you can connect all the points of your graph and all the points in between are also solutions, if everything on this line, every single point is a solution to our graph, that's a continuous function. It has like an infinite number of solutions within set parameters. A discrete function is when you can't include numbers in between. So for example, it would be like if I was talking about the number of children, of grown children somebody has. If we're looking at older couples and we're talking about the number of grown children they have, well, like if I graphed it and I said like age of couple and number of kids up here, I couldn't, if they're, 40, 50, 60, 70, whatever, 1, 2, 3, a 40-year-old couple could have 1 kid, or they could have 2 kids, or they could have 3 kids, but they couldn't have anything in between, right? They couldn't have anything in between 2 and 3 kids. So I could put a dot here. Maybe if they're 50, they have this many. Maybe if they're like whatever on average, let's just say. But I could not connect these because if this is a 40-year-old couple, this is 50. When they're 45, that would fall in between, and you can't have in between 1 and 2 kids when they're grown, right? I get like when you're pregnant or whatever people say, that's different. But grown adults, you can't have 2.5 grown adults, right? You either have 1 or 2 or 3. It's not continuous. So I could not draw a line through this. That's called a discrete function, when they have specific answers and nothing in between those answers works. I hope that's not too confusing. So for our example, this could be continuous, right? Because at any time on the trail, he could be a different distance from the trail. There's no It's not like, okay, he can either be 1 foot from the trail or 2 foot from the trail, but he can't be in between. No, actually, in fact, he does have to be in between to get from 1 to 2, right? So this would be a continuous function. So we'll say continuous. And we already talked about explaining kind of what it did. As time went on, the dog got further away from the trail, then he kind of stayed the same amount, then he got further away, then he stayed the same, then he came back to the trail. All right, and then for 19 and 20, identify the independent and dependent variables. Well, first of all, the independent variable is always on the x-axis, always. And the second thing about the independent variable is time is always independent. Time doesn't speed up or slow down for anybody. Nothing makes time change. Time always ticks by at the same amount of time. So it doesn't depend on anything, right? But other things depend on time. So the dependent variable is always our y-axis, our y value. It goes up and down on a graph. X goes side to side. And this value depends on what this is, right? Always. That's what independent and dependent variables are. So here in this graph, excuse me, we have year on the bottom, and we have, I can't read this. What did I even say? Newspaper sold, sorry. It's blurry and I can't read, I'm blind. Newspapers sold here. So does the amount of time, the amount of years that go by, depend on how many papers are sold? Or do the number of papers sold depend on what year they were sold in? Right? So our independent variable is always time, whether it's years, days, months, seconds, minutes, whatever, always time. So independent is our years. Oh, there's the bell. Lovely. And then our dependent variable is the number of newspapers sold. Dependent number of papers. Whatever's on the y-axis is always our dependent variable. Number 20, write a description of what the graph displays. Well, let's just kind of talk about it. We're not going to write it. Let's just talk about it. So here it shows the year, starting at 2006, 2007, 2008, 2009. So it's pretty modern. It's not like it's back in the 30s. It's pretty modern. What, 15 years ago or so. And then on the side here, we have newspapers sold in thousands. So 10,000, 20,000, 30,000, 40,000, 50, whatever. So it looks like back here in 2006, there were almost 80,000 papers sold, right? And then in 2007, that number went down to 70,000. In 2008, it went down to 60,000. And then for the next couple years, it didn't change. It leveled off at 60,000. So in 2006, we had the most amount of papers sold, 80,000. Then it went down kind of at an average rate of 10,000 per year until we got to 2008. And then it stayed the same at 60,000 papers a year for a couple years. Okay, so if we were going to describe what's going on here, that's what's going on. We'll say talked. All right, number 21. We only have 25, so we're almost done. Each day, David drives to work in the morning, returns home for lunch, drives back to work, and then goes to the gym to exercise before he returns home for the evening. Draw a reasonable graph to show the distance David is from his home for a 2-day period. Okay, so what they want us to do here, I can just make it little here. Here's our graph. Remember, time is always the independent variable on the x-axis, side to side, and it's over 2 days. So we're going to say, since it breaks it up into morning, lunch, and evening, we'll break it up into those times, right? But it's over 2 days, so we have morning, lunch, evening, morning, lunch, evening, morning, lunch, evening, morning, lunch, evening. And this is talking about the time of day, talking about the time of day, so it goes on our x-axis. And then up and down, we're going to say that's his distance from home. And does it say how far in the morning? No, it doesn't give us numbers. So we're just going to say it's distance from home, distance. But we're not going to make little tick marks because it doesn't give us any numbers, so we don't know. It's more of like a theory kind of thing, okay? So it says, each day, David drives to work in the morning, okay? So in the morning, like let's say before anything happens, he starts off at home. So his distance from home is 0. He's at home. And in the morning, he drives to work. So he goes to work. So he goes, that's his distance from home increases. He returns home for lunch. So there's 0 distance between him and home for lunch because he's there. and then he drives back to work, and then goes to the gym to exercise before he returns home for the evening. So we'll say he goes back to work, and then maybe somewhere else, and then he returns home in the evening. Right? Here's work, and then somewhere, the gym or whatever. It could go down, too. Maybe the gym is closer to his house. It doesn't say. Excuse me. Draw a reasonable graph to the distance he is from home for a 2-day period. So if this is 1 day, then the same thing's going to happen for the next day, right? He's at home. His distance from home is 0. Oh, there's the bell. Sorry. His distance from home is 0. Then in the morning, he drives to work. So it's going to go up here again. Then he comes home for lunch. And then before he goes home in the evening, he goes back to work. And then he goes to the gym. And then he comes back home, right? Something like that. So over a 2-day period, distance from work is going to look something kind of like this. This would be a graph to represent his distance from home. All right, number 22. Determine whether this equation represents a function. How do we know if we have a function? None of the x values can ever repeat, right? So for every x value, there's one y value. So here, if I plug anything in for x, am I ever going to get, for the same number x, could I ever get 2 different numbers for y? No, the only time that can happen is if we square variables, or if they're an absolute value, or if something funny is being done. Whenever you just have an x and a y and there's no exponents, there's nothing else funny being done, for every value you put in for x, you're going to get a different value for y. So your x's are never going to be repeated, right? If I put in a 1 for x, I'm always going to get a whatever, 1 answer for y. I'm never going to put the same number in for x and get a different answer for y, right? So this would be a function. For every value I put in for x, I would get a different value for y, because x and y are just regular variables. They have an exponent of 1. There's nothing funny going on. So determine whether it represents a function. Yes, it does. The only time it would not is if this is being squared, if one of these is being squared or raised to the 3rd power, if there's exponents, or if there's absolute value. If that happens, then this might not be a function, and it just kind of depends. You have to look at the situation. But if they're just plain, again, it is a function. Number 23, if f of x, which is, remember, it's just y, if y equals 3x squared minus 2x plus 1, find 2 times f of r. Okay, so we've got our equation, f of x, which is negative 3x squared minus 2x. So then it wants us to multiply the whole thing by 2, and wherever I see an x, I have to replace it with what's in here, which is an r. So I'm going to have 2 times 3r squared minus 2r. Oh, I left that plus 1 off up top. Might be. Okay, so this is what our equation would look like. If blah, 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 find blah, blah, blah. Once we get to this point, now we can simplify, right? Unless they specifically ask you for this answer, if it just says find whatever, you want to simplify it as best you can. So we're going to distribute, excuse me, negative 6r squared minus 4r plus 2. And we can't combine any of these terms. None of them are like terms. So this would be our answer. If f of x is negative 3x squared minus 2x plus 1, then 2 times f of r is negative 6r squared minus 4r plus 2. Right? That would be our solution. And 24 and 5, the last 2 questions of the whole review. Interpret the y-intercept of the graph and interpret the end behavior of the function. The y-intercept of the graph is where our graph crosses the y-axis, which looks like it's right at 5. So what's our graph telling us here? Ohio population, the population in Ohio. So down here we have years since 19, is that 100 or 08? It doesn't look like a 0, but I'm just going to say it's a 0 because I can't read what it says. Okay, so here's 25 years since 1900, 50 years since 1900, but if this is 25 years since 1900, what is it, 0? That must be the year 1900, right? So we'll put 1900 right there. It's been 0 years since 1900 on the y-axis. And what is our population? That's these numbers. and it's in millions. So 5 million people in 1900. That's what it's telling us. Interpret the y-intercept of the graph. It's telling us that there were 5 million people in Ohio in 1900. 5 mil people in OH in 1900. And then here we have interpret the end behavior of the function. So the end behavior is over here where this arrow is, right? So basically we're asking as y gets bigger, or sorry, as x gets bigger, as the years go on, what's our graph doing? Sorry. As x gets bigger, as the years get bigger, what's our graph doing? Is it going up, or is it going down, or is it staying constant? What does it look like it's doing? Well, to me, it looks like since it's going up, 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 up here, you could either say that it's still increasing, even though it looks pretty small. You could say it's still increasing, or you could say it looks like it's pretty constant. It's not changing anymore. Now it's going more in a straight line, right? I would accept either one of those answers because that's what this end behavior looks like. So we could say 150 years since 1900 would be 2050, the year 2050. So or we could say by 2050, the Ohio population remains constant. Or you could say slightly increases each year or something like that. But as the years go by, this line doesn't go down, the population doesn't decrease, but it kind of looks like it's not increasing that much anymore. It kind of levels off. Okay, bonus, we have a simplification problem. Might as well do it since we're here. We have parentheses up at the top, so this becomes 7. Here, I'll zoom in a little. We have 21 divided by, I can't see that very good. This printing is terrible. This is a division sign. 21 divided by 3 plus 4 times 2. So 21 divided by 3 is 7, plus 4 times 2 is 8. So I'm going to simplify that. 6 squared plus 7 squared minus, and then in these parentheses we have 7 plus 8, which is 15. Excuse me, all over 14 minus 3 times 1 to the 4th power plus 2 to the 3rd minus 5 plus 1 times 2. So the only thing I can simplify here is 5 plus 1. I'm going to just copy everything else. 3 times 1 to the 4th plus 2 to the 3rd minus 6 times 2. Oh, you can't even see that, darn it. Okay, so this is where I'm at after I simplified. Okay, so now I want to do all the exponents, get rid of all of them, right? So 6 squared on top is 36, plus 7 squared is 49, minus 15, all over, ignore the page number here. 14 minus 3 times 1 to the 4th power is just 1. 1 to the anything power is just 1. So 14 minus 3 times 1, I can even just go ahead and multiply that. 3 times 1 is just 3. Plus 2 to the 3rd power, 2 times 2 times 2 is 8, minus 6 times 2. So now I have multiplication left down here, and that's it. 6 times 2 is 12. Now I just have adding and subtracting. That's it. Excuse me. So all I'm going to do here is just go in order from left to right on the top and on the bottom. So 36 plus 49 is 85. 85 minus 15 is 70. And then on the bottom, 14 minus 3 is 11. 11 plus 8 is 19. And 19 minus 12 is 7. So I've got 70 over 7. Can I divide 70 by 7? Yes, I can. The answer is 10. So let me know if you have any questions. You can go back and rewatch this slowly if you need to. I know I took forever, but I hope that this helped you guys. Good luck on your test.